Okay, welcome back. Let's share. There we go. Okay, then again, we have here another session to learn Python. And as I mentioned before, I'm going to have more time to do this. Okay. There we go. Okay. Well, first, I wonder. Okay, let's oh. Let's first get my app ready. There we go. Okay. Let's see. I am in the right device. Okay. Accept. There we go. Yeah, where is the part where I see? Oh, Smart View. There we go. This is the one. Yes. Now, just to make sure that my phone is not going to. There we go. I'm charging the phone now. There we go. I don't see. There we go. Now, let's get to work. I'm going to put my phone over here. Whoa. I can barely, I wonder if I can use this as, yeah, like this, maybe? Yeah, this makes more sense. But I might need to reposition this. Okay, first, let's see. Whoa, I'm very bad. I had very bad connection right now. Whoa, my connection is going to shit. Why? My internet connection is dying very badly. What's going on? Okay, let's see. Transform. Reset transform. But that doesn't make much sense. Oh, well, anyway. Who cares, right? Well, there it is. Okay, let's get back to work. The internet is very slow right now. I wonder what's going on. I'm not downloading anything. Or uploaded, maybe? Maybe that's the issue. Whoa, what the hell? It's dropping really badly. What the hell is this? Okay, let's try to close everything. Okay, I got in the previous video, I got a description for generators. I may like to watch that again. Okay.
All right, this massive list finally finished being entered in memory. But remember our key terms. Remember how I said a list is an iterable? What was an iterable? Well, an iterable is any object in Python which we're able to loop through. Underneath the hood, it has the dunder iter method. So when the object is created, this iter allows us to have an iterable object that can be iterated over. To iterate something, or...
Oh, wait, before going on, I may like to... share. It's going to be way easier from here. Okay, let's see. What? Wow, internet is really slow. What's going on? Yeah, internet is dying on me right now. I should probably stop the clock. There we go. Okay, what's going on? Okay. Okay, I'm getting some errors here. Yeah, it seems like YouTube is not getting enough data from me. What the hell? Yeah, look at that. Hello, hello, testing 1, 2, 3. Testing 1, 2, 3. What? Hello, hello, testing 1, 2, 3. Testing 1, 2, 3. Testing 1, 2, 3. Testing 1, 2, 3. Hello, testing 1, 2, 3. It's dying on me. Okay, never mind. Let's try to share. And get this part. Oh wait, I already shared that one. So I already shared. Never mind. Okay then, let's back to work. You may indeed call this work. I think, well, it feels like work to me.
Iteration is the act of taking an item from an iterable, doing something to it, then going to the next one. When we use loops, like for loops or while loops, we call that iteration. It's the process itself. And generators are actually iterable. That is, everything that is a generator is iterable. You can iterate over them. But not everything that is iterable is a generator. For example, a range is a generator. So that is always going to be iterable. But a list is an iterable, but it's not a generator. So a generator is a subset of an iterable. I know those are a lot of words. Hopefully you're still with me. The difference between a generator and a regular iterable is the way we implement them. So let me show you a general way to create a generator. Let's clear this code and define our own generator. And generators are usually functions. Just like range is a function, generators are usually created this way. So let's say generator function. And this generator function is going to have a for loop that is going to loop over a range, just like we had before. But the difference here, let's actually bring back the code that we had previously. Just going to comment this out so we can see it in terms of difference.
Okay.
The generator function is going to create, let's say, these many items. But instead of returning like we would in a regular function, we're going to use a keyword called yield. And here, we're going to yield the I, so the item. So notice the difference here. Now, if we want, just like here, we can pass a number like this, but instead of returning and appending this list and creating all this data, we're going to use yield. Now, what does yield do? You see, yield pauses the function and comes back to it when we do something to it, which is called next, something that we'll cover shortly. So yield, it says, hey, pause the function, just yield I, give I, and when you tell the generator function, I'm going to print the item. Now here, what's going to happen is we're going to loop over the generator function, and we'll give it to the generator function, let's say 1,000 for now, and we're going to print each item. In the generator function, because this is an iterable, it's going to run, and it's going to loop, and for every item in this number, so that is range, we're going to yield Y. So it's going to keep looping and looping, and when we come back, when we loop over, we're going to run this, and the yield comes back and runs again. Let me show you what I mean. I'm going to comment this out as well, and just click run here. Did you see that? What we just did here is similar to down here, but instead of having to create that list in memory, it just kept going one by one. We only held one item in memory, and we used it however we wanted to. In our case, all we did was print item. Let's explore this yield keyword a little bit more. What does it actually do? Let's say that we want to multiply this by 2, just like we did here in our original example.
Yeah, it pauses.
But now, instead of doing the for loop, let's just call the function and say g equals generator function, and we're going to give it 100. Now, if I print g and I click run, you see that I get a generator function. Remember, this is just a standard way in Python that we can create a generator function using the range and the yield keyword. But this yield keyword gives us some power, because if I just return here, we're not going to get anything special. As a matter of fact, we're just going to get a value. Instead, by using the yield keyword, what we're able to do is to turn this into a generator function that can do, well, this. I can say next g. Now, if I print next g in here, and I click run, I get 0. But here's the cool part. If I do next g twice, and then one time here and print it, I get 4. Why is that? Remember, the yield keyword pauses the function. So what just happened here is I ran the function with 100. The first item in range 100 was 0. Right? Now here, before I was even able to run this, it said, hey, this is a generator function. But the first time you run it, give the output 0 times 2. So that the very first time we run this function, and I click run, make sure we change that to y, this is just 0. If I run it again, like this, then we have, now I want you to iterate and go to 1. So 1 times 2, what is that? Well, 1 times 2, let me fix that like this. Make sure this is I get 2, because 1 times 2 is 2. If I run it again, and I click run, I get 4.
Yeah.
You see, yield, like I said before, pauses the function and comes back to it when next is called. So if it has
when next is called,
it becomes a generator. It keeps track of this state, what we call the value, and it only keeps the most recent data in memory. For example, 4. It remembers that, because on, let's say, line 14, if I do print next g, it remembers that previously this I was, well, 4. So now, even though this piece of code already ran, if I run it on line 14, I get 6. Because 3 times 2, well, is 6. Remember, because it gets multiplied by 2. So let me ask you this. If, let's say, I only do a range of 1 here, and you know, let's just remove multiply by 2. If I do this, and I run next more than once, what is going to happen? If I click run here,
an error,
I get
an
a stop
exception.
iteration. You see, next
Stop
can be called
iteration
as many times as we want,
exception.
as many times until this range expires. And when we exceed the number of items in the range, well, we get a stop iteration error to let us know that, hey, you can't call next anymore. We've reached the end of line. And when we use for loops with ranges, it actually detects this underneath the hood for you. So we're able to run a function like this where we use range, even though range is a generator, because the for loop automatically says, hey, I'm going to stop looping as soon as I encounter this stop iteration. But that's hidden away from us as users. Now, this concept of generators is pretty hard to understand, especially at first. So you might have to look at this a couple of times. But over the next couple of videos, I want to convince you how powerful they are. I'll see you in the next one. Bye-bye.
Generators performance. And this was the video that I stopped watching.
I multiply by 5 and keeps going.
Wait.
From memory, any old. Okay, I can't see you, but I know what you're feeling. You're doubting me right now. You're thinking generators are useless. You keep saying that they're fast and performant, but I don't really get it. This yield keyword and this next, and honestly, it just doesn't make sense. Let me convince you that they're true power. I'm going to select all of these and just delete them, because I want to go back to an example that we've used before. Remember when we created the decorator performance in our decorator section? Using this performance decorator, let's minimize it. I have 2 functions for us. A longtime function that uses a range, and another longtime function that uses a range and then converts it into a list. So remember, one creates a list, and then from that list that's created in memory on our computers, it's going to go 1 by 1 and multiply things by 5. Versus a range, which is a generator that comes built into Python, that is going to just 1 by 1 hold 0 in memory and multiply by 5, hold 1 in memory by multiply by 5, and keeps going, and removes from memory any old numbers. What do you think the performance of both of these will be? Let's test it out. And by the way, I'll link to the exercise so you can test it out yourself and play around. So let's do long time, and then long time 2. Place your bets, get ready, let's find out. The first function, long time, took 1.6 seconds, and then the second function took almost twice as long. That's a pretty big difference, right? But right away we can tell, all right, this is definitely more performant than well, long time 2. Let's run it again just to test our assumptions, make sure it's correct. This time it took 1.8 and then 2.6. All right, this is so much faster, even though they both do the same thing. And think of this if you were Google. Think about how much data Google has. If you were Google, and imagine if this was even bigger,
billions, trillions.
If you can perform a task that much
Trillions of records
a lot less resources than what Google
save
has,
at one
they
time.
would love you. Because with generators, we're able to not hold things in memory, not have to consume all that resources.
Yeah,
Process data.
memory is expensive.
And look over here. I was able to solve this function in 16 seconds. I mean, yeah, that took a long time, but long time 2 actually couldn't even make it. It killed the process. If this was a Google server, that's a server that just died and is completely useless.
Yeah.
So generators are really, really useful when calculating large sets of data, particularly if we're using long loops, where we don't really want to store that memory. And we don't need to calculate everything at the same time, maybe one by one. And a lot of libraries in Python, underneath the hood, use generators instead of using lists because they're so much faster. So remember, to create a generator, all we have to do is create a generator function that we want. And then in here, we can just simply loop over some value that perhaps we give it to a range, or we can just accept as parameter. All we need to do is simply yield that
something.
result. And do whatever we want in this block, but make sure we pause the function so that later on it can be used as a generator function. So we can do something like a for loop and say item in gen function and give it some sort of parameter.
Under the hood of generate. Okay.
Welcome back. I want us to understand how things work underneath the hood. So I'm going to show you 2 examples of implementing our own for loop and then implementing our own range function. So the first one is our for loop. So I'm going to say special for loop. Underneath the hood, all it's doing is receiving an iterable, and then we're going to say iterator is going to equal an iterable. Now, for us to have an iterable, we have what we call an iter function that accepts the iterable we just passed. Now, this iter function is going to allow us to use the next function.
Wait.
All it's doing is receiving an iterable, and then we're going to say iterator is going to equal an iterable. Now, for us to have an iterable, we have what we call an iter function.
Iter function.
The iterable we just passed. Now, this iter
Okay.
function is going to allow us to use the next function on this iterable. So stay with me.
Okay.
I'm going to say while true, I want to try. And in this try block, we'll say iterator. And we can perform, let's say, some sort of operation here if we want, or we can just call next iterator. Let's
try
something here just so we see what the iterator is.
Okay.
And then finally, I want us to stop when we have the stop iteration exception. Remember the one that we saw where there's no more items in the iterable.
We need
Here,
to
we can
delete
just
the semicolon.
And make sure that I have the colon set correctly. So now, if I do special for loop and give it a list,
Colon.
1, 2, 3, and I
Okay.
click run, check it out. I loop through some iterable objects using next. And you see that this object exists in the same memory space, even though we're constantly looping through it through 1, 2, 3. So this is how for loops work.
Oh, yeah.
When we do for, let's say num in an
They use one
it's going to go through everything.
address.
It's going to turn it into an iterable, and it's going to keep running and keep calling next iterator on it over and over and over until we finish the end of the line and then break out of the loop. And how do we check the actual values of the iterator? Well, remember, the next function is going to output whatever the item is next. So if I do print here and I click run, I get 1, 2, 3.
Oh, okay.
I can just do times 2 if I wanted to. Click run. And there you go. Our special for loop just multiplied our list by 2. That's it. That's how for loops really work. But what about ranges? Can we create our own range function? We absolutely can. And this is a fun one. Let's create a class. And this class, because at the end of the day, we're just going to create an object that has actions that we can do. So I'll say my gen for my generator. And this is going to mimic what a range does. So I'm going to have a class. And this class will have a init function. We'll have a self, a first and last. So this is how a range, we're able to say start with this and end with this. And in here, we'll do the typical self.first equals to first, and then self.last equals to last. And I'm using a class here because, remember, we're just creating our own data type, our own special range in Python. Now, we have our simple generator. And ideally, we want to be able to say gen equals, and instantiate my gen to have, let's say, 0 to 100, just like we would with a range. And ideally, we can say for I in gen, and print I. Because, I mean, that's how we're able to use ranges, right? So how can I make this work? Well, we can use our dunder methods. So remember how we have the iter to get an iterator and use next on them? Well, we have a define dunder that is iter. And iter allows us to create an iterable. So in our case, I'll say self, and here I'm just going to return the actual class.
Okay.
And then finally, we want to be able to run the next function on our gen because we saw how for loops work. We need to be able to use the iter and then the next on them. So once again, we can use a dunder method, which is conveniently called next.
Next.
And this is into Python. So if I do here self, and all we want to do here is to let it know how we want next to work. Well, I'll say if, and we need some sort of state or data to keep track of where we are. Remember how generator functions remember where they are? Well, we can create a class object attribute. So I can say current equals to 0. So this is where we are currently on our iteration. And say my gen.current, as long as that is less than self.last, which will be the 100 here. If that's the case, well,
increment current
to equal my gen.current. I want to increase my gen.current by 1 because we want to say, hey, we're moving up to the next location. And then return the number. Because that's how next works underneath the hood, right? We increment our current location by 1. And we're simply returning the number, which is, well, in our case, it's going to be 0.
That's what next
we
does.
keep going. Well, until current is no longer bigger than last. In that case, we're simply going to raise a stop iteration because there's no more things to iterate over. Let's see if this works.
Oh, okay, because it's a try.
And look at that. It's all working.
That's the range.
Through my generator and print I from 0 all the way to 99. Again, if we go back to our example here, and I know this is a little hard to look at it at first.
Yeah.
But all I did was say I want an if function to have the option of first and last. And I'm going to want to be able to iterate through this object that I'm going to create. And I also want to be able to use the next, which for loop, if you remember from our previous example, needs. So I'm going to say for item in gen, just loop through it. I'm able to loop through it because this is now an iterator. And I'm able to use the next value on it because I allow us to loop and constantly increase by 1 until we keep returning the number until my gen.current becomes 100. And 100 is not less than 100, which is self.last. So it's going to raise a stop iteration. The for loop automatically catches that so it doesn't error out and it stops looping. That's how things work underneath the hood with range. Now, you don't need to know this. You're not going to be asked in your day-to-day to implement this, but I wanted to show you that this is how things work. I think that's important.
Exercise, Fibonacci numbers.
Let's do a famous exercise. And this might come up as an interview question. We're going to try and implement Fibonacci numbers. And Fibonacci numbers are like this. The first number is 0. Then the second number is 1. They always start with 0 and 1. Then this is what happens. We add 0 with 1 to equal the next number. We add 1 with 1 to equal the next number. We add 1 by 2 to get the next number. 2, 3 to add the next number. 5, 8 to add the next number. So on and so forth. As you can see, this grows exponentially. Well, it grows really high, really fast. And this sort of numbering actually shows up in nature a lot. But it's also an interesting problem because these numbers, although at the beginning grow really, really slowly, they become larger and larger and larger. And it becomes a problem that can really hog up the resources. So this is what I want you to do. We're going to create a function, fib, that takes a number. And in here, this number is going to be the index number of the Fibonacci. So for example, if it was the 20th number, it should have this. So if I wanted, let's say, fib 20 here, in that case, I want you to return all these numbers using generator. So that is 1 by 1 until we get to this location.
Okay.
Now there's two ways of doing this. We can do it with a list or we can do it with a generator. And you'll notice that with a generator, it's a lot easier to do than with a list because eventually with a list, you're going to run out of resources. So what I want you to do is to output on here the numbers that you see here all the way until 20. And if you want, you can keep increasing that number and see what happens. And as a bonus, you can try implementing this with a list as well. So it displays in a giant list as well. Pause the video if you want here. Otherwise, I'm going to keep going.
Okay. Let's try to do that one. Generator example. So this is how it works. But in the previous video, and that's one thing that I didn't do. Oh my God, the network is really going down here. Yeah, I don't know what's going on. The network is going down. I guess after this chapter, I'm going to take a break. But anyway, on the previous video over here,
To loop and constantly.
I might like to see. There we go. Okay. Let's see. It's creating a class called myGenerator. Wait. Oh, never mind. Class myGenerator. Okay. The current value is class level. It's a class level attribute. That's the current. Okay. Def init. So I'm going to override 3 methods: init, iter, and next. So init is it's a basic constructor. I'm going to ask for a first value, the last value, and just assign them to the object attributes, object level attributes. Okay. def, I'm going to override init. Whoa, okay. Besides self, I'm going to need, okay, let me, there we go. Why is wrong? Okay. And here, the first parameter and the last parameter. Well, those are called just that way. So, and okay, assigning itself that first going to be equals to the first, the parameter first, and again self last is going to be equal to last, and that's it for that one. Another is going to be iter. I don't remember what iter does. I guess I'm going to find out. Okay, what do? You return self. That's it? Okay. You need this in order to return yourself. That's iter. And next is receiving self as a parameter. And it's asking if myGen.current is minus. Okay, nice. Def. The name is next. Okay. The Thunder method next is going to be. It's going to be doing what? I'm going to ask if the current value is lesser than the last value of this object. Okay. myGen.current. Okay, I need to ask. Is this okay? Yes. Okay, this is not okay. And I'm going to ask self.last. That's the attribute. Okay, if that's okay, then the number variable is going to receive the current. myGen.current. So I'm going to make a copy of the current value before doing anything else. And then I guess I'm going to, there we go. And then I'm going to increase myGen current to +1. Then I'm going to return num. Okay.
I know this is a little hard to look at it at first, but all I did was say I want an init function to have.
Wait, I have a return statement, a rise statement in the end. Rise stop iteration. So I understand that there is a try somewhere at the beginning. And there we go. It's def special for. Oh wait, no, this is. Okay, this is before. Class myGen. Here's define an iter. I don't see a try anywhere.
Current is no longer bigger than last. In that case, we're simply going to raise a stop iteration because there's no more things to iterate over. Let's see if this works.
I lost my video. What's going on? Oh my god. I'm losing video now. The internet seems to be, oh what? What the hell? I don't know what's going on. Okay. Stop iteration.
And look at that. It's going to be 0. And we want to keep going, keep going, keep going. Well, until current is no longer bigger than last. In that case, we're simply going to raise a stop iteration because there's no more things to iterate over. Let's see if this works. I'm going to run this.
Okay, I just rising something here because it's going to loop through everything, and while if I order to iterate over something, I'm not going to be able to do that. I'm not going to be able to return, so it's going to go straight for the rise stop iteration. Okay, I get it now. Okay. So that's it for this one here. So this is how the range more or less works. Okay. This part, I was really confused about this part, but I think I have it cleared out. And in order to test it, he's creating a gen variable, assigning a call to the creating a myGen object, assigning it to the gen variable, and creating a loop. Let's try that and try the code. myGen 1 to 100, and he's creating a for loop for I in gen, I think. Yeah, and then just print I. Okay. Okay, now let's try. There we go. I'm printing out 100 values. Okay. I guess I'm going to shut down the computer for a while and see why the network is way too slow now. Yeah, I don't know what's going on. Something's going on. Well, I have like 1 minute and a half yet, so here is the Fibonacci number.
Going to keep going.
There we go. Stop. So I'm going to come back to this when I return, but now I guess I'm going to shut down the computer for a while and see if the network is going to recover because it's been very slow. I don't know why. I'm going to restart everything, check out my connections, and I see I'm losing video from time to time. Although I see that the stream is just keeps going, but anyway. Well, thank you for coming in, and I'm going to be back in a short while. I'm going to use the opportunity to sleep 1 hour maybe, and come back around 7 p.m. Central Standard Time and continue. I'm going to be on my bed, resting a little bit and tweeting something. You can find me on Twitter at Jorge Escobar. I'm going to how do I there we go. So this is my Twitter profile. It's at Jorge Escobar. That's my name basically. I was lucky enough to sign into Twitter like 13 years ago. 13 years ago, yeah. But anyway, I tweet about the stupid things. I shitpost a lot. The only thing that I take seriously, I believe, is work, and since that's not here anymore, well, and that's my bell to, that's my signal. Well, thank you for coming in.